one more thing before we break. Now we did a CI and we did planning for sufficient precise CIs. We can do confidence interval also. I'll not dwell on this. This is, what did I say there? Did I say it right? We could do hypothesis testing if I said it wrongly. We can do hypothesis testing. These are the steps in hypothesis testing. Let's not spend time on these now. That was a repeat. We've seen that a number of times in the course. The hypothesis test today looks very much like one sample hypothesis testing for the mean mu, as we met quite some weeks back. Actually, P is the mean of the binomial. So in a way today we also do hypothesis testing for a mean. But now we just call it P because it really has the interpretation as a proportion and not a mean for some quantitative measurement. But it's still, conceptually, it's a mean for the system. Anyway, the proportion, we could hypothesize, for instance, in a poll, could the proportion be 50-50? Or do we know statistically that we don't believe in a 50-50 split? That could be one hypothesis test that we could do. Here is the way, one way. There are several ways, but the one we will show explicitly here. To do such a hypothesis test in this setting, again, we have these similar assumptions that the n is large enough compared to the hypothesis. It's pretty straightforward in a way. We compare the data with the hypothesis, right? With the expected value under the hypothesis. We would observe, for instance, 600 voting for Macron, and we would compare, if I had an n of 1,000, the expected number of Macron voters in such a sample would be 500, right? 1,000 times 1/2, which is the P0 here, that would give the expected 500. That's the way to compare data with hypothesis in this sense, and we divide by the binomial standard deviation of that number that we can recognize. That's our standardized test statistic that compares data and hypothesis. It follows under the null hypothesis the standard normal distribution, and we can use the normal distribution to find p-values or to compare with critical values, either way we like. Which this slide says, either we find the p-value or we compare with the critical value. That, if we want to formalize it, if the observed set is either too large, too far to the left, or too far to the right, we reject the idea of the hypothesis being true, right? If the observed test statistic becomes large, either minus or plus, we reject. Because that expresses that the data is far away from the hypothesis and that we don't believe the hypothesis, right? That's just as we've been used to. Is half of all people in Denmark left-handed? Could be the hypothesis. What do you think the result will be? Let's see. We compare the 10 with the expected out of 100. That's 50. That makes 40 divided by the standard deviation of the binomial. That makes a standardized test statistics of -8. Is -8 an extreme value in a standard normal distribution? Yes, it is, right? Standard normal is ±2, 95%, ±3. We have 99 point something percent or something like that. So -8 is extremely extreme. So data is far, far away from this hypothesis. So of course, with 10 out of 100, if someone has a coin and he tricks you, and you check the coin and it gives 10 heads and 90 tails, you're pretty certain in your gut that this is not a fair coin, right? We would all of us have this, I hope, feeling that 10 out of 100, that's really, really unlikely in a 50-50 assumption. So we reject. We could also go exactly find the p-value which would be quantifying how often do we go beyond 8 in a standard normal distribution. That's pretty rare. So there is very strong evidence against the 50-50 thing if I observe 10 out of 100, right? I hope you can follow the bit rapid there. Here's the repeat of the argument. Game. You don't get out of Macron and Le Pen today. Who's going to win? I'm speechless. No. I know I'm pushing you a bit here because I'm giving you a method and then you get 30 seconds to apply the method for the first time in your life. And of course that's pushing you a little bit. So fair enough. Should we just go check that I'm right before we break ourselves? We said 600 out of 1,000, right? Now you correct me if I confuse every one of us. I just add this one to make sure that the computation done by the R function is exactly the one that I've shown you, and not just a little twist of it, but exactly the same. That's pretty small, right? So 600 out of 1,000 is extremely unlikely if the population was 50-50. Now I didn't grab this 60% out of nothing. That was the poll I saw this morning. 61% was the act. I didn't check the N. I was in a bit of a hurry. But that's around the polling level at the moment, with around 60% in favor of Macron. So that's where we are. Macron is going to win, pretty surely. If things are okay. Statistically, that was not a political statement. Macron wins. Great. How well planned was that? Anyway, let's do our usual 15 minutes break, and I start 3 after.